All right, let's do this. Imagine, just for a second, you're not from around here. You've just landed on Earth. You're looking at, well, everything. The trees, the rocks, the sky, your spaceship, and you can't help but ask one single massive question.
What is all this stuff, anyway? I mean, really, what's it made of? It's probably the most basic yet most profound question there is. And the answer? Well, the answer unlocks the instruction manual for pretty much the entire universe. And we call that manual chemistry.
Okay, so first things first. All this stuff needs a name, right? In the science world, we call it matter. Let's break down what that actually means.
And the definition is actually super simple. If something takes up space and has mass, boom, it's matter. It's the phone in your hand, the water you drink, and yeah, even the air you're breathing right now. That's matter too. But, just having a label for it doesn't really tell us much. To get the real story, we've got to go smaller, like a lot smaller.
We're about to shrink down from our world, the one we can see and touch, to a scale that's almost impossible to imagine. A world where millions of these things could dance on the head of a pin. We're talking about the absolute fundamental building blocks of everything.
And that brings us to this, the atom. I love this analogy. Think of it as the universe's ultimate Lego brick. Seriously. But just like with Legos, if you want to build something cool, you first have to understand the brick itself. What's it made of? So every atom has this super dense core, right in the middle, called the nucleus. And crammed in there are two kinds of particles, protons, which have a positive charge, and neutrons, which are, you guessed it, neutral. Then you've got these little electrons with a negative charge just whizzing around that nucleus in a cloud. That's the basic setup. And this simple little blueprint, it's the foundation for literally everything. Now this is the part you really got to get. The identity of an atom, what makes it what it is, boils down to just one thing. How many protons it has. That's it. It's like its unchangeable ID card. If it has one proton, it's hydrogen, always. 6 protons, you're looking at carbon, the stuff of life. 79 protons, now you're talking gold. You change the number of protons, you change the entire element. It's that simple. So how many different kinds of these atomic Legos are there? You might think there'd be millions, but nope. Right now, we know of just 118. That's the entire alphabet the universe uses to write everything. And here's the crazy part. Most of what you see, you, me, the planet, were built from just a small fraction of those. It's like writing epic novels using only the first 5 or 6 letters. So the next big question is, how do these letters link together to form words?
Right, so how do these little guys link up? Well, it turns out atoms aren't really the lone wolf type. They're super social. They're always looking to connect with other atoms. And the way they do that, the way they hold hands, is really the magic of chemistry. We call these connections chemical bonds.
You can think of a chemical bond as the handshake that holds atoms together. And it all comes down to those electrons zipping around on the outside. See, atoms can either share their electrons with a neighbor, like a friendly handshake, or one atom can straight up give an electron to another. Either way, that interaction creates this powerful force that links them up.
And when you get a group of atoms bonded together like that, you have what's called a molecule. I bet you know the most famous one on the planet, H2O, water. It's not just a random soup of hydrogen and oxygen. No, it's a very specific team. 2 hydrogen atoms firmly bonded to 1 oxygen atom. And that specific team-up creates something totally new. And if you want proof of how powerful this bonding is, look no further than this. On one side, you have sodium. It's a metal so volatile it literally explodes if it touches water. On the other, chlorine, a poisonous gas. Yikes. But get them to hold hands to form a chemical bond, you get sodium chloride. You know it as table salt, the stuff you put on your fries. From explosive and toxic to perfectly edible. That right there is the magic of chemistry. Now, this whole process of atoms getting together and breaking up, it's not a one-time thing. It's happening all the time, all around us. It's this constant, beautiful dance of change. And that dance has a name, a chemical reaction. So what exactly is a chemical reaction? It's really just a reshuffling of dance partners. The atoms break away from their old partners and find new ones. The atoms themselves are still there, nothing's created or destroyed. They're just rearranged into totally new combinations, creating totally new stuff. Let's walk through the steps of the dance, okay? You start with some hydrogen and oxygen gas. Then you add a little spark of energy. That's the music starting. All of a sudden, their old bonds break apart. For just a moment, the atoms are all single, ready to mingle. Then, bam, they snap together into new, more stable partnerships. And just like that, what was once two separate gases has become liquid water. And the cool thing is, you can often see this dance with your own eyes. Ever see something change color all of a sudden? Or seen bubbles fizzing up where there weren't any before? Or felt something get hot? Or seen a bright flash of light like a fire? Anytime you see that stuff, you are literally watching atoms breaking up and pairing up in real time. You're watching a chemical reaction happen.
All right, so we've zoomed all the way down to the tiniest building blocks of the universe. Now, let's zoom all the way back out and see how all this tiny stuff actually runs your entire world. Think about it. When you cook dinner, that's chemistry. The soap you use to wash your hands, that's chemistry too. The battery that's powering whatever screen you're watching this on right now. Yep, pure chemical reactions. The medicine that helps you feel better. Even the very act of taking a breath. It is all, every bit of it, that same endless dance of atoms. So here's the final mind-blowing takeaway. It's not just that chemistry is around you, it's that chemistry is you. From the electrical signals firing in your brain that create your thoughts, to the contractions of your heart muscle, you are one giant walking, talking, thinking chemistry experiment. So no, you're not just some alien observer trying to understand Earth stuff. You are Earth stuff. Welcome to the club.